we are having so many solar energy technologies. So broadly, we can classify solar energy technologies into two parts: solar thermal and solar photovoltaic. So using these two technologies, we can tap this solar energy for the welfare of the humanity, or for the require to meet the requirements of the humanity, and at the same time to make this earth a better place to live by cutting down the consumption of fossil fuels. So what happens broadly in solar thermal technology and solar photovoltaic technology? So in solar thermal technologies, we receive solar energy, right? And we produce heat, right? We produce heat. And in solar photovoltaic technology, we receive solar energy and we directly produce electricity. So these are the two ways, broadly two ways to utilize solar energy. So here in the subsequent discussions, I will only focus on solar thermal technologies, right? So let's see all the solar thermal technologies we have. So broadly, we have got two types of solar thermal technologies: non-concentrating and concentrating. Non-concentrating means we are just receiving solar energy, and without any increase in its intensity or flux, we are utilizing it directly, right? And the other one is the concentrating. Concentrating helps us to achieve higher flux at a point. We saw that we are receiving 1361 watts per meter square, which was the solar constant which we just saw, 1361, right? So but by the time it reaches the earth's surface, it further reduces. So we have got enough solar energy, but it is distributed over a very wide land area. So as a result of this, in this heat flux which is coming from the sun is not very much useful to produce a workable power plant which can produce electricity for our requirement. So we use concentrating solar thermal technologies which focus sun rays over a very small area, and we will see it through some animations in the subsequent discussion how the solar radiation is focused. And there are two ways to focus this solar radiation. One is called point concentrating. We focus all the solar radiation at a point, okay? And the second one is line concentrating. We focus the solar radiation over a line. And point concentrating are of two types: solar tower and parabolic dish. Line concentrating are of two types: parabolic trough and linear Fresnel reflector. So these four technologies, there are few more sub classification of these technologies, but broadly there are these four: point concentrating two types, solar tower and parabolic dish; line concentrating of two types, parabolic trough and linear Fresnel reflector. So solar tower, we will see first here, the point concentrating technology. They are of two types. One, there is a receiver. In all the solar thermal technologies, we will, when the sunlight comes, there would be one collector and then there would be one absorber. Okay, so these are two important components: collector and absorber. Absorber we also call receiver, absorber or receiver. Okay, so sunlight falls on the collector, get reflected or focused by a collector to the receiver, and receiver produces the desired heat. Okay, so in a surround field, the collectors are all around a receiver. This is the receiver or absorber. These are collectors. These are collectors. Okay, they are all around. And whereas the another type of, this is the second type, where we have got uh, collectors only on one side, only this side. There is no collector this side. Okay, only on one side. and the sunlight comes and gets focused on the receiver. Here the sunlight comes and get focused on the receiver from all around. Okay, but here the sunlight comes and get focused only on one side of the receiver. Right? And we will see why we use this type of solar tower and when we do use this type of solar tower. So this is the surround field solar tower. Through an animation, I tried to explain. These are all the collectors. We call them heliostats. Heliostats means they are stationary, focusing the sunlight over the receiver. This is the receiver, and I'll see the flux distribution. This is how the flux distribution is obtained, and which is what this is how the heat is produced inside this receiver, and there is a working fluid flowing. Okay, so this heat is absorbed by this working fluid, which is then ultimately sent to the power plant for electricity production or for various other purposes. It need not be just a power plant. It could be a process industry. It could be um, um, metallurgical industry or some other industry where you need high temperatures. Then this is polar field, where the second type of solar tower, uh, where the field is or the heliostats are only on one side. The collectors or heliostats are only on one side, and the sunlight comes and gets focused on the receiver. And this is the flux distribution. This is the flux distribution on the surface of the receiver, and this also there is a working fluid flowing, and that working fluid takes the heat from this absorber or receiver and send it to the power plant for production of steam and hence running the turbine. Okay. Now the question is why there is only one side. So this type of field we use when we are away from the equator, right? So when we are away from the equator, say we are in the northern hemisphere, then we know that the sun rises in the east, sets in the west, and most of the time it remains on the south. So if you have got any uh, mirror or heliostats on this side, they won't be effectively utilized because they would be facing the back side of the sun. The sun will be facing their back side, which is a non-reflecting side. So there is no use of putting any heliostats this side. Therefore, the heliostats are only on this side. This way, we save on plant cost, and hence we try to reduce the cost of production of electricity. Then this is one of the line concentrating types I discussed initially. There are two types of concentrating technologies: point concentrating and line concentrating. This is a line concentrating one where there is a parabola, and this parabola has been given shape, has been extruded. This we call parabolic trough. The sunlight falls on this parabolic trough, gets focused on the receiver, and there is a working fluid flowing. It's same as in the solar tower we saw, and this working fluid heats up and it produces, which is sent to various applications, either power plant, just like in the solar tower. And the flux distribution has been shown here, right? This is the flux distribution which has been shown here on the surface of the receiver, and there is a fluid flowing inside this tube. Usually this is tubular in shape, and say there is fluid flowing inside the tube to produce the necessary to absorb the heat from this receiver and make use of it for various needs. Then the second line concentrating type. So there it was a parabolic trough which was focusing all the solar radiation along a line. Here also we are focusing the solar radiation along a line, but here we have got flat mirrors. These are flat mirrors. All right, they they are individually rotated, but they are rotated only in one axis direction. Okay, they are rotated like this as the sun moves from one location to another location. So we need to adjust the tilt of these mirrors so that they all the time focus the solar radiation on the absorber, because absorber is the place where the working fluid is flowing, which we have to heat up. Right? Now this is the point concentrating type again. The first point concentrating type was solar tower. This is the second point concentrating type. This is called parabolic dish. So in here we have got a parabolic dish. Okay, this sunlight falls on this parabolic dish. Okay, and it's getting focused at the absorber or at the receiver, and there are tubes here inside the receiver which through which working fluid is flowing, and you this way you take out the hot fluid which you can use for some other purposes, various other purposes. So here we have shown the heat flux distribution on the surface of the receiver. So these are all various technologies we discussed. Thank you.